welcome to this video. Today we're going to do this problem. So take two adjacent sides of a unit cube, which will be a cube with a side length of 1. For one of them, draw the inscribing circle. So you can see we chose this side. We drew the inscribing circle. And for the other one, so like this top one, draw the inscribed circle, right? Now find the distance between the two circles. And just to clarify, the distance is not 0. The circles, so first of all, clarify a few things. A distance means you have 2 points, one on this circle, one on the second circle. And the distance between the circles will be the minimal distance between these 2 points. That's the first. That's to clarify what distance is. Second, the distance is not 0, because you might think, well, we have this circle and it's touching right in this point. But in reality, when we're saying circle, we only mean the perimeter of the circle. So it's like only this. So it's only this like one-dimensional line that goes around in a loop, which makes a circle, and same with this one. And we want to find the distance between them, which I previously explained what the distance means. Okay, so let's begin. So first of all, you might think, well, the minimal distance is probably like 2 special points, like this one and this, like this one and this one, or this one and this one, or something like that. But in reality, they're actually, it's the points that aren't really like points on the cube or the top of the circle or something like that. Something like that gives the minimal distance. In reality, it's some like point here in the middle, which draws a line to some weird point here, which gives the minimal distance. But so how can we actually figure this out, this minimal distance? Well, it's hard to think about the distance between 2 circles. It's much easier if we take the spheres that are encompass these circles. So if we take the center of the cube, right, and then we make a sphere, one that contains the inscribed circle and the second that contains the inscribing circle, right? So if we have, so what we'll get is like a sphere and another sphere inside it. Right? It's a bit of a bad drawing, but you get what I mean, right? A sphere inside that one, and the distance between them will just be point on here, and this length will be which will obviously be the distance between the spheres, will be just the difference of the 2 radii. So, the minimal, so like the distance between the 2 spheres we drew, the 2 spheres in here, would be the difference of their radii. But how do we know that 2 points that give this distance here are also 2 points that lie on the original circles? Right? Maybe just, so basically what we're saying, the minimal distance will get the minimal distance when the point here and the point here that we're like choosing to find the minimal distance, if the line between them intersects the center of the cube, well then in the sphere, then they're like the 2 closest points that they can be, which will give out the smallest distance possible. Then but then how do we know that 2 points like that even exist? Well, let's show that. So take the center of the cube and draw like a cone. So basically like a ray or a line from this point to one of the points on the inscribing circle, and then you can like move this line around, right? So if we draw it to the, if we take the line that is to the top, it would intersect like the cube at some point here, so it will be inside the inscribed circle. But if we take some point like the corner of the cube, this is clearly outside the circle, the inscribed circle, meaning that when we move from this point to this point, so the ray like goes like this, eventually there will have to be some point on the inscribing circle that will exactly hit the perimeter of the inscribed circle, right? So something like this, and meaning that there indeed are 2 points which will give out the smallest distance they can give. And so now we just have to figure out that actual distance. So I want to find the radius of the sphere which has the inscribed circle, and the sphere which has the inscribing circle, which is the same as just figuring out the distance from the center of the cube to one of the corners, and figuring out the distance from the center of the cube to one of these like middle of these segments. So the first one, if we have our cube here and we have the center and we want to figure out this distance, right? This is this distance from the center of the cube, so right here, to one of the corners, right? So to this corner, it's just half of from one point to the exact opposite point, right? Because it's a cube, everything is symmetrical. So basically this is half the length of the main diagonal. But the length of the main diagonal we can easily figure out, right? We know it's a unit cube, so this distance is 1, and this distance is 1, which makes like this length of the diagonal of this face square root of 2. And then if we take this line in the diagonal, right, so this and this, it might not look like it, but because this line is perpendicular to this entire plane, since it's a cube, then it will be perpendicular to any line on this plane, which if we take the specific line, the diagonal, it means that in the 3-dimensional space, this will be a right angle. So this is 1, this is square root of 2. This length by the Pythagorean theorem, this is the square root of 1 plus square root of 2 squared, so square root of 3. Meaning that the distance from the center to one of the points is half that, which is root 3 over 2. Now I want to subtract the distance from one point, so from the distance from the center of one side to the center. Well, you can think of it, if we have this line, so if we have this line and we move it to one of the faces, so we have this face, this will be the center of the square, and the length we're trying to figure out is this, right? We moved it, you can think of it as making a parallelogram, right? So this length is the same as this length, but this length is just half the length of the entire diagonal. The length of the entire diagonal is very easy to figure out, since this is 1, this is 1, this is a right angle. Length of the diagonal is square root of 2, meaning that the half that length is square root of 2 over 2. And so this is the difference of the radii, and we proved that the distance between the circles has to be at least this number, the spheres, by the arguments with the spheres, and we know there are 2 points that make this circle, like the argument of like the ray that moves from this point to this point. And, which means that this is the smallest distance we can have between a point on one circle and a point on the other circle, which by definition is the distance between the circles, which gives us the final solution. Root 3 over 2 minus root 2 over 2. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting content and things like this in the future. And finally, that's it.